This session is for OCR FP1 and the topic we're looking at is roots of polynomial equations from June 2010, question 7. So if we have a look at the question, we're given a quadratic equation x squared plus 2kx plus k equals 0, where we're told that k is a non-zero constant and the equation has roots alpha and beta. And we're asked to find a quadratic equation with roots alpha plus beta over alpha and alpha plus beta over beta. So the first thing it's just worth reminding ourselves about is that if we have a quadratic equation ax squared plus bx plus c equals 0, then the roots, and the roots are alpha and beta, then the sum of the roots, alpha plus beta, is minus b over a, and the product of the roots is c over a. So that's the sort of theory behind the question, and that's what we need to know. So if we apply that to this question, where we're told that x squared plus 2kx plus k equals 0, then the sum of the roots, alpha plus beta, well, in our case, a is equal to 1, since we've got 1x squared, and b is equal to 2k, so the sum of the roots will be minus 2k, and the product of the roots, which is up here we had c over a, well, c is equal to k, and again a is equal to 1. So the product of the roots is k. We're trying to find an equation with roots alpha plus beta over alpha and alpha plus beta over beta. So we need to find the sum of those roots. So if we do that, then let's take a common denominator of alpha beta, and then we'll have over here alpha into alpha beta goes beta times, so we'll have beta lots of alpha plus beta, and then beta into alpha beta goes alpha times, so we'll have alpha lots of alpha plus beta. Now if you look at that carefully, you'll see that again we've actually got a common factor in these two terms on the top, a common factor of alpha plus beta, and it will go into the first term beta times and into the second alpha times. So actually we can simplify that quite easily. And of course, beta plus alpha is just the same as alpha plus beta, so we can replace that by minus 2k, and then the product of the roots is k, so that means that the sum of the roots is equal to 4k. And in order to find the quadratic, we now need to look at the product of the roots. But of course the product of the roots will just be alpha plus beta over alpha times alpha plus beta over beta, which of course just turns out again to be 4k if we just compare that with what we've got up here. So that means the product of the root is also equal to 4k, which means that the equation, the quadratic equation then, is going to be x squared minus 4kx. So just remember that because the sum of the roots is 4k, then that means that b is going to be minus 4k, and then the product of the roots is 4k, which means that c will be equal to 4k. So our quadratic equation is x squared minus 4kx plus 4k equals 0. In terms of marks for that question, if we just have a look at the marks that are actually awarded for each bit, then we get a mark, a method mark, just for writing down, or a statement mark for writing down each of these, the sum and product of the roots. We get a method mark for attempting to find the sum, and we get an accuracy mark for finding the sum of the roots to be 4k. And then we also get a method mark for attempting to find the product of the two roots and an accuracy mark for getting 4k again. And then at the end we get a statement mark for writing down the correct equation. So 7 marks in total for the question. So don't forget that if you want to watch further revision videos for any of the modules that you're doing, then it's worth going to the Further Maths website and you will be able to follow the link there.